Hey, what is up, you guys? Tutor Jane here, and today's video is a response to a comment I got on my TikTok where I posted this maths challenge. So I went through this question timed, and someone said that they didn't know how to do it and they wanted me to make a tutorial on it. So here we are. So I've just rubbed everything out, and I'm going to talk you through the reasoning behind the different steps that I took to answer this question. So this question says that we have a line, y equals x plus 1, and this line is intersecting another graph, y equals x squared minus 3x minus 11, at these points A and B. Now we need to find the coordinates of A and B. Now, before I show you how I did this, I'm going to draw some graphs. Let's say you had, oh, that's too thick. Let's say you had x and y. Perfect. So if I draw a parabola like this, and I'll also draw a line like that. Okay, cool. So I don't know what the equation for this graph is. I've just drawn both of these randomly, but in general, this U shape here is what we call a parabola. So this is the graph of y equals ax squared plus bx plus c, where a, b, and c will have any value, like any values. So here our a is 1 because there's a 1 in front of the x squared, our b is -3, and our c is -11, for example. Now, this line here is y equals mx plus c, which you're hopefully familiar with, where m is the gradient. That tells you sort of how steep this line is from the horizontal, and the plus c is the constant, which tells you, well, it's the y-intercept, so it tells you where this graph crosses the y-axis. So anyway, that's a basic rundown of these two shapes of graphs. So this is a quadratic graph and this is a linear graph. Now, in our question, we have the same kind of thing. We have a quadratic graph, x squared minus 3x minus 11, and we have a linear graph, x plus 1. So we've been told to work out where they intersect. Now, these aren't the same as the particular question. This is just an example. But here you can see when we have a quadratic graph that has this U shape and we have a line graph that goes straight through it, it's going to intersect our quadratic graph at 2 points. So conceptually, this is what our question is trying to get us to figure out, is we're trying to figure out what these points are. So again, these aren't the exact same coordinates probably that we're looking for, A and B, but this is just an example that shows you that when a line graph intersects a parabola, it will intersect typically at 2 points. You can also have a situation where you have a line graph that touches the parabola at 1 point. So that then acts as a sort of tangent to our U-shaped graph. And in this case, you're only going to have 1 point of contact. So there'll be one coordinate solution for where these two graphs cross. But in our particular case, we've been told that there are two solutions because we've been told that the line graph intersects the U-shaped parabola at 2 points A and B. Now the question says to work out what A and B are. Now to do this, all we have to do is take the equation for our quadratic graph, our ax squared plus bx plus c, and we have to make it equal the equation of our line graph. Because when we make these two graphs equal each other, we can then solve for one of the variables, so x, and that will tell us the x coordinates, these values here, of the points of intersection. So again, all we have to do is take these two equations, make them equal each other, and solve for x to work out the x coordinates. So that is what I did here. So can we make these two graphs equal? We can, because our quadratic graph is of the form y equals blah, 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 and our linear graph is also of the form y equals blah, blah, blah. So the y and the y are the same, so we can make these two graphs equal each other. So we can do x squared minus 3x minus 11 equals our linear graph here, x plus 1. Now, all we're going to do is rearrange the equation and solve for x. So step 1 was making these two graphs equate each other. Step 2 is solving this equation for x. So let's move all of this to the left-hand side. So we get x squared minus 3x minus 11 minus x minus 1 equals 0. Collecting the like terms, we get x squared minus 4x minus 12 equals 0. Now we have a quadratic, and we've got a quadratic equation. Now we need to solve for x. Now there are three different ways of solving quadratic equations. We can simply factorize, we can complete the square, or we can use the quadratic formula. I've briefly covered all of these in my shorts, so do have a look at these videos if you don't know what I'm talking about. I also briefly covered factorizing quadratics in my introduction to quadratics YouTube, which I will link here maybe. So do check that out as well. So in this case, this is actually a nice, easy equation, and we can factorize. So to factorize the quadratic, we need to find two numbers that multiply to give our constant here, minus 12, that add together to give minus 4. So the two numbers that are immediately obvious to me are 2 and minus 6. So 2 times minus 6 gives you minus 12, and 2 plus minus 6 gives you minus 4. So 2 and minus 6 are going to be our numbers when we factorize. So then we put x plus 2 in brackets and x minus 6 in brackets equals 0. I'm not going to do this here, but if you wanted to, you could expand these brackets and you'll get the exact, and you'll get the original equation from up here. So not going to do it, but if you were to expand the brackets, you would get the original equation. As I said, if you wanted to look into this more, you can check out my quadratics introduction video up here. So now that we've factorized our quadratic and made it equal 0, we can now solve both parts of our factorized expression. So we get x plus 2 equals 0. And we get x minus 6 equals 0. So therefore, x equals minus 2 and x equals 6. So now we've solved our quadratic for x. So what we have now are the x coordinates of where these two graphs intersect. So theoretically, we have these values here. So in this case, of x values are minus 2 and plus 6. Now the issue is we have to find our y values for those x coordinates. Up here. We have to find our y values for those x coordinates. And we do that by substituting these x values back into one of these original equations to figure out what the y is, because the equation is y equals x plus 1, or y equals our quadratic up there. So the easiest one to substitute into is the linear graph. So y equals x plus 1. So I'm going to put that down here. Y equals x plus 1. So therefore, when x is 2, y is minus 2 plus 1 minus 1. So here we have our first set of coordinates, minus 2 minus 1. Perfect. Now when x is 6, y is going to be 6 plus 1, which is 7. So our second set of coordinates are 6 and 7. And that's all. I hope I explained that well. And that this makes more sense to you now. Please do let me know if you're finding my maths challenges fun and useful. If you have any more topics or questions that you want me to cover in more depth like this, just let me know somewhere in the comments of some video and I will do it. Anyway, that is all for this video. Have a nice evening and I will see you later. Bye for now.